Learning objectives. In this chapter, the user would learn the following in detail: an overview of C++ programming, Smalltalk, Java, loops and decisions, structures and functions, objects and classes, arrays and pointers, inheritance, virtual function. An overview of C++ programming, Smalltalk, Java. An overview of C++. The C++ programming language provides a model of memory and computation that closely matches that of most computers. In addition, it provides powerful and flexible mechanisms for abstraction, that is, language constructs that allow the programmer to introduce new types of objects that match the concepts of an application. Thus, C++ supports styles of programming that rely on fairly direct manipulation of hardware resources to deliver a high degree of efficiency, plus higher level styles of programming that rely on user defined types to provide a model of data and computation that is closer to a human's view of the task being performed by a computer. These higher level styles of programming are often called data abstraction, object-oriented programming, and generic programming. The design and evolution of C++. C++ was designed and implemented by B. Journey, Stroustrup at AT and T. Bell Laboratories to combine the organizational and design strengths of Simula with the C's facilities for systems programming. The initial version of C++ called C with classes was first used in 1980. It supported traditional system programming techniques and data abstraction. The basic facilities for object-oriented programming were added in 1983, and object-oriented design and programming techniques were gradually introduced into the C++ community. The language was first made commercially available in 1985. Facilities for generic programming were added to the language in the 1987 to 1989 time frame. As the result of widespread use and the appearance of several independently developed C++ implementations, formal standardization of C++ started in 1990 under the auspices of the American National Standards Institute (ANSI) and later the International Standards Organization (ISO), leading to an international standard in 1998. During the period of standardization, the Standards Committee acted as an important focus for the C++ community, and its draft standards acted as interim definitions of the language. C++ design aims. C++ was designed to deliver the flexibility and efficiency of C for systems programming. The abstraction mechanisms provided by C++ were specifically designed to be applicable to programming tasks that demanded the highest degree of efficiency and flexibility. Aims. C++ makes programming more enjoyable for serious programmers. C++ is a general-purpose programming language that is a better C, supports data abstraction, supports object-oriented programming, supports generic programming. Design principles. The design rules for C++ are listed under the headings: General rules, Design support rules, Language technical rules, Low-level programming support rules. General rules. C++ evolution must be driven by real problems. C++ is a language, not a complete system. Don't get involved in a sterile quest for perfection. C++ must be useful now. Every feature must have a reasonably obvious implementation. Always provide a transition path. Provide comprehensive support for each supported style. Don't try to force people. Design support rules. Support sound design notions. Provide facilities for program organization. Say what you mean. All features must be affordable. It is more important to allow a useful feature than to prevent every misuse. Support composition of software from separately developed parts. Language technical rules. No implicit violations of the static type system. Provide as good support for user-defined types as for built-in types. Locality is good. Avoid order dependencies. If in doubt, pick the variant of a feature that is easiest to teach. Syntax matters, often in perverse ways. Preprocessor usage should be eliminated. Low-level programming support rules. Use traditional dump linkers. No gratitudes. Incompatibilities with C. Leave no room for a lower level language below C++ except assembler. What you don't use, you don't pay for zero override rule. If in doubt, provide means for manual control. An overview of Smalltalk programming language. Smalltalk is the language that started the object-oriented programming revolution. Smalltalk first embodied and articulated the fundamental concepts of OOP. Not only did Smalltalk introduce the basic ideas of object, class, message, method, and inheritance, it ran with them. Languages that came after Smalltalk like C++ and Java have been mere limitations, dwarfed by the shadow of the past and crippled by their compromises. These newer languages have introduced few new concepts and in many ways have failed to realize the OP ideals as well as Smalltalk. Today, Smalltalk is a mature evolved system. Comparing it to say Java, Smalltalk is highly efficient, extremely portable, easy to use and every reliable. Smalltalk is still the most enjoyable language to program. Ideas pioneered by the group that developed Smalltalk. Number 1, the mouse. Number 2, bitmapped graphics displays. Number 3, windowing systems. Number 4, mouse driven menus. Number 5, object-oriented programming. Number 6, personal computers. Evaluation of Smalltalk. Smalltalk was developed at the Xerox Corporation's Palo Alto Research Center, PARC, in the decade of the 1970s. This was a 10-year project that culminated in the release in 1980 of the Smalltalk 80 system. This included the Smalltalk language, the Smalltalk system, a large body of Smalltalk code, the Smalltalk virtual machine, complete documentation and source code. In 1980, Smalltalk system booted to life on a number of platforms and the OOP revolution began as researchers began to study Smalltalk. The idea of object-oriented programming turned out to be a major revolution in programming languages. Immediately after Smalltalk 80 was released, all important previous languages were retrofitted with object orientation. The introduction of the common LISP object system, CLOS, Object Pascal, and Object C. There was even a mutant thing called Object COBOL. Basic OOP concept and terminology. The basic concepts of Smalltalk: objects, fields, OOPs, classes, methods, messages, inheritance, receiver, dynamic binding. Object. The Smalltalk object is very similar to the Java or C++ object. In particular, each object is stored in memory and several fields which can point to other objects or contain primitive data values. Each object is an instance of a class. The only difference between a record and an object is that the object contains a single special field that identifies which class the object belongs to. Field. In C++, Java and Smalltalk, there is a single hidden field in every object. In Smalltalk, this field is called the class pointer. In other languages, this hidden field is called the vtable pointer or dispatch table pointer. OOPS, that means OOPS. In Smalltalk, references are called object-oriented pointers or OOPS. Classes. Each object belongs to exactly one class. We say that each object is an instance of its class. Classes are related in a tree-shaped hierarchy. So, each class is exactly one superclass except the class at the root of the tree. So, Smalltalk has single inheritance. Smalltalk uses the terms subclass, superclass and inherits from. C++ uses the term derived class, but we prefer to say subclass instead. When the programmer defines a new class, two things must be described. Number 1, how the objects will be represented, and number 2, how the objects will behave. Methods and messages. A method is like a function except that is applied to a specific object. The method is invoked on an object or sent to an object. The object in question is called the receiver. Every method is invoked on a receiving object. Methods in Smalltalk are similar to methods in Java and C++, where they are called member functions. The method body is a sequence of executable statements. There is an important distinction between methods and messages. A method is a body of code while a message is something that is sent. A method is similar to a function. Sending a message is similar to calling a function. An expression which invokes a method is called a message sending expression. When a message is sent to an object, a method will be selected and executed. Since we cannot know in general the class of the object until runtime, the method cannot be selected until the message is actually sent. This is called dynamic binding. And Java, C++ and Smalltalk all have it. The Smalltalk object model. Smalltalk uses the term instance variable to mean a field. So we say an object contains several instance variables to mean the same thing as an object contains several fields or an object contains several data members. In Smalltalk, there is only one primitive data type and it is called small integer. A small integer is stored as a 31-bit 2 complement integer. Smalltalk is an untyped language. The compiler does not know the types of variables. Any variable may contain either a pointer, an OOP or a small integer, and at different times the same variable can contain both small integers and OOPs. In Smalltalk, the primitive values are first class objects. There is a single class called small integer, and when the programmer adds a new method to it, it can be used in exactly the same way as any other method. In Smalltalk, we can send messages to small integers. There is a single class called character and there are exactly 256 instances of this class. New instances of this class may not be created. Thus, each different character is represented as an object. The Unicode encoding is also handled using other classes. There is also a class called Boolean There are two instances of this class and they are given the names true and false. An overview of Java. Java programming languages was originally developed by Sun Microsystems, which was initiated by James Gosling and released in 1995 as core component of Sun Microsystems Java platform. The new 12 versions were renamed as Java SE, Java EE and Java ME respectively. Java is guaranteed to be write once, run anywhere. Java is object oriented. In Java, everything is an object. Java can be easily extended since it is based on the object model. Platform independent. Unlike many other programming languages including C and C++, when Java is compiled, it is not compiled into platform specific machine, rather into platform independent bytecode. This bytecode is distributed over the web and interpreted by virtual machine JVM on whichever platform it is being run. Simple. Java is designed to be easy to learn. If you understand the basic concept of OODB, Java would be easy to master. Secure. With Java's secure feature, it enables to develop virus-free, tamper-free systems. Authentication techniques are based on public key encryption. Architectural neutral. Java compiler generates an architecture-neutral object file format which makes the compiled code to be executable on many processes. With the presence of Java runtime system, portable. Being architectural neutral and having no implementation dependent aspects of the specification makes Java portable. Compiler in Java is written in ANSI C with a clean portability boundary which is a POSIX subset. Robust. Java makes an effort to eliminate error-prone situation by emphasizing mainly an compile time error checking and runtime checking. Multi-threaded. With Java's multi-threaded feature, it is possible to write programs that can do many tasks simultaneously. This design feature allows developers to construct smoothly running interactive applications. Interpreted. Java bytecode is translated on the fly to native machine instructions and is not stored anywhere. The development process is more rapid and analytical since the linking is an incremental and lightweight process. High performance. With the use of just-in-time compilers, Java enables high performance. Distributed. Java is designed for the distributed environment of the internet. Dynamic. Java is considered to be more dynamic than C or C++ since it is designed to adapt an evolving environment. Java programs can carry extensive amount of runtime information that can be used to verify and resolve accesses to objects on runtime. Java basic syntax. Java program can be defined as a collection of objects that communicate via invoking each other's methods. Object. Objects have states and behaviors. Example, a cat has states, color, name, breed as well as behaviors, wagging, eating. An object is an instance of a class. Class. A class can be defined as a template, blueprint that describes the behaviors, states that objects of type support. Methods. A method is basically a behavior. A class can contain many methods. It is in methods where the logics are written, data is manipulated, and all the actions are executed. Instance variables. Each object has its unique set of instance variables. An object's state is created by the value assigned to these instance variables. Basic syntax. Case sensitivity. Java is case sensitive, which means identifier hello and hello would have different meaning in Java. Class names. For all class names, the first letter should be in uppercase. When several words are used to form a name of the class, each inner word's first letter should be in uppercase. Example, class, my first Java class. Method names. All method names should start with a lowercase letter. If several words are used to form the name of the method, then each inner word's first letter should be in uppercase. Example, public void my method name. Program file name. Name of the program file should exactly match the class name. When saving the file, you should save it using the class name. Remember, Java is case sensitive, and append Java to the end of the name. If the file name and the class name do not match, your program will not compile. Example, assume my first Java program in the class name. Then the file should be saved as my first Java program name. Public static void main. String arg. Java program processing starts from the main method, which is mandatory part of every Java program. A simple Java program, for example. Now you can see the program. Steps to save the file. Compile and run the program. Open Notepad and add the code as above. Save the file as my first Java program, Java. Open a command prompt window and go to the directory where you saved the class. Assume it's C. Type Java C, my first Java program, Java, and press enter to compile your code. If there are no errors in your code, the command prompt will take you to the next line. Assumption, the path variable is set. Now type Java, my first Java program, to run your program. Hello world printed on the window. Now you can see the program. Java identifiers. All Java components require names. Names used for classes, variables, and methods are called identifiers. In Java, there are several points to remember about identifiers. They are as follows. All identifiers should begin with a letter A to Z or small a to Z, currency character $, or an underscore. After the first character, identifiers can have any combination of characters. A keyword cannot be used as an identifier. Most importantly, identifiers are case sensitive. Examples of legal identifiers: age, $salary, underscore value, underscore one underscore value. Examples of illegal identifiers: 123 ABC, hyphen salary. Java modifiers. Like other languages, it is possible to modify classes, methods, etc. by using modifiers. There are two categories of modifiers: access modifiers, default, public, protected, private. Non-access modifiers, final, abstract, strict FP. Java variables. Types of variables in Java: local variables, class variables, static variables, instance variables, non-static variables. Java arrays. Arrays are objects that store multiple variables of the same type. However, an array itself is an object on the heap. Java enums. Enums were introduced in Java 5.0. Enums restrict a variable to have one of only a few predefined values. The values in this enumerator list are called enums. With use of enums, it is possible to reduce the number of bugs in code. Explained in the example very clearly. Output. Size medium. Java keywords. The following list shows the reserved words in Java. These reserved words may not be used as constant or variable or any other identifiers. We can see in the table very clearly. Commands in Java. Java supports single line and multi-line commands very similar to C and C++. All characters available inside any command are ignored by Java compiler. Now we can see the commands. Using blank lines, a line containing only white space, possibly with the command, is known as a blank line, and Java totally ignores it. Inheritance. In Java, classes can be derived from classes. To create a new class, if there is already a class that has some of the code required, then it is possible to derive new class from the already existing code. This concept allows the reuse of fields and methods of the existing class without having to rewrite the code in a new class. In this scenario, the existing class is called the superclass and the derived class is called the subclass. Interfaces. In Java language, an interface can be defined as a contract between objects on how to communicate with each other. Interfaces play a vital role when it comes to the concept of inheritance. An interface defines the methods a deriving class subclass should use, but the implementation of the methods is totally up to the subclass. Arrays and pointers. Arrays. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of the same type. Instead of declaring individual variables such as number 0, number 1, etc. and number 99, you declare one array variable such as numbers and use numbers 0, numbers 1 and etc. number 99 to represent individual variables. A specific element in an array is accessed by an index. All arrays consist of contiguous memory locations. The lowest address corresponds to the first element and the highest address to the last element. Declaring arrays. To declare an array in C++, the programmer specifies the type of the elements and the number of elements required by an array as follows. This is called a single dimension array. The array size must be an integer constant greater than 0 and the type can be any valid C++ data type. For example, to declare a 10 element array called balance of type double, use this statement. Initializing arrays. You can initialize C++ array elements either one by one or using a single statement as follows. The number of values between braces cannot be larger than the number of elements that we declare for the array between square brackets. Following is an example to assign a single element of the array. If you omit the size of the array, an array just big enough to hold the initialization is created. Therefore, if you write array with the fourth index will be fifth, that is last element, because all arrays have 0 as the index of their first element, which is also called a base index. Following is the pictorial representation of the same array we discussed above. Accessing array elements. An element is accessed by indexing the array name. This is done by placing the index of the element within square bracket after the name of the array. For example, following is an example which will use all the above mentioned three concepts via declaration, assignment and accessing arrays. The program makes use of setW function to format the output. When the above code is compiled and executed, it produces the following result. C++ arrays in detail. Arrays are important to C++ and should need lots of more detail. There are following few important concepts which should be clear to a C++ programmer. Now we can see the concept and description in the table. Multi-dimensional array. The meaning for this is called C++ supports multi-dimensional arrays. The simplest form of the multi-dimensional array is the two-dimensional array. Pointer to an array. The meaning is you can generate a pointer to the first element of an array by simply specifying the array name without any index. Passing array to functions. You can pass to the function a pointer to an array by specifying the array's name without an index. Return array from functions. The meaning is C++ allows a function to return an array. Pointers. A pointer is a variable whose value is the address of another variable. Like any variable or constant, you must declare a pointer before you can work with it. The general form of pointer variable declaration is shown below. Here, type is the pointer's base type. It must be a valid C++ type, and variable name is the name of the pointer variable. The asterisk is being used to designate a variable as a pointer. Following are the valid pointer declaration. The actual data type of the value of all pointers, whether integer, float, character or otherwise, is the same, a long hexadecimal number that represents a memory address. The only difference between pointers of a different data type is the data type of the variable or constant that the pointer points to. Using pointers in C++. There are few important operations which we will do with the pointers very frequently. Define a pointer variables. Assign the address of a variable to a pointer, and finally accesses the value at the address available in the pointer variable. This is done by using unary operator star that returns the value of the variable located at the address specified by its operand. Following example makes use of these operations. When the above code is compiled and executed, it following result. Address of operator ampersand. The address of a variable can be obtained by preceding the name of a variable with an ampersand sign known as address of operator. For example, this word would assign the address of variable my variable to FOO by preceding the name of the variable my variable with the address of operator ampersand. We are no longer assigning the content of the variable itself to FOO but its address. Let's assume, in order to help clarify some concept, that my variable is placed during runtime in the memory address 1776, that means 1776. The values contained in each variable after the execution of this are shown in the following diagram. First, we have assigned the value 25 to my variable, a variable whose address in memory we assumed to be 1776. The second statement assigns FOO the address of my variable, which we have assumed to be 1776. Finally, the third statement assigns the value contained in my variable to bar. This is standard assignment operation as already done many times in earlier chapters. The main difference between the second and third statement is the appearance of the address of operator ampersand. The variable that stores the address of another variable like FOO in the previous example is what in C++ is called a pointer. Pointers are a very powerful feature of the language that has many uses in lower level programming. Dereference operator star. A variable which stores the address of another variable is called a pointer. Pointers are said to point to the variable whose address they store. An interesting property of pointers is that they can be used to access the variable they point to directly. This is done by preceding the pointer name with the dereference operator star. The operator itself can be read as value pointed to by. Therefore, the following with the values of the previous example, the following statement. This could read as bas equal to value pointed by FO. And the statement would actually assign the value 25 to bas since FOO is 1776 and the value pointed to by 1776 following the example above would be 25. It is important to clearly differentiate that FOO refers to the value 1776 while star FOO with an asterisk star preceding the identifier refers to the value stored at address 1776, which in this case is 25. Notice the difference of including or not including the dereference operator. I have added an explanatory comment of how each of these two expressions could be read. The reference and dereference operators are thus complementary. Ampersand is the address of operator and we can be read as simply as address of. Star is the dereference operator and can be read as value pointed to by. Thus, they have a sort of opposite meanings. An address obtained with and can be dereferenced with star. Pointers and arrays. The concept of arrays is related to that of pointers. In fact, arrays work very much like pointers to their first elements, and actually an array can always be implicitly converted to the pointer of the proper type. For example, consider these two declarations. The following assignment operation would be valid. After that, my pointer and my array would be equivalent and would have very similar properties. The main difference being that my pointer can be assigned a different address, whereas my array can never be assigned anything and will always represent the same block of 20 elements of type integer. Therefore, the following assignment would not be valid. Output 10, 20, 30, 40, 50. Pointers and arrays support the same set of operations with the same meaning for both. The main difference being that pointers can be assigned new addresses while arrays cannot. Pointer initialization. Pointers can be initialized to point to specific locations at the very moment they are defined. The resulting state of variables after this code is the same as after. When pointers are initialized, what is initialized is the address they point to, that is, my pointer, never the value being pointed, that is, star my pointer. Void pointers. The void type of pointer is a special type of pointer. In C++, void represents the absence of type. Therefore, void pointers are pointers that point to a value that has no type, and thus also an undetermined length and undetermined dereferencing properties. This gives void pointers a great flexibility by being able to point to any data type, from an integer value or a float to a string of characters. In exchange, they have a great limitation. The data pointed to by void pointers cannot be directly dereferenced, and for that reason, any address in a void pointer needs to be transformed into some other pointer type that points to a concrete data type before being dereferenced. One of its possible uses may be to pass generic parameter to a function. Example: pointers to functions. C++ allows operation with pointers to functions. The typical use of this is for passing a function an argument to another function. Pointers to functions are declared with the same syntax as a regular function declaration, except that the name of the function is enclosed between parentheses and an asterisk is inserted before the name. Inheritance. Inheritance is the capability of one class to acquire properties and characteristics from another class. The class whose properties are inherited by other class is called the parent or base or superclass, and the class which inherits properties of other class is called child or derived or subclass. Inheritance makes the code reusable. When we inherit an existing class, all its method and fields become available in the new class. Hence, code is reused. All members of a class except private are inherited. Purpose of inheritance: code reusability, method overriding, use of virtual keyboard. Basic syntax of inheritance is shown. While defining a subclass like this, the superclass must be already defined or at least declared before the subclass declaration. Access mode is used to specify the mode in which the properties of superclass will be inherited into subclass, public, private or protected. Example of inheritance is shown very clearly. Inheritance visibility mode. Depending on access modifier used while inheritance, the availability of class members of superclass in the subclass changes. It can either be private, protected or public. Public inheritance. This is the most used inheritance mode. In this, the protected member of superclass becomes protected members of subclass and public becomes public. Private inheritance. In private mode, the protected and public members of superclass become private members of derived class. Protected inheritance. In protected mode, the public and protected members of superclass becomes protected members of subclass. Table showing all visibility models. Types of inheritance. In C++, we have 5 different types of inheritance: single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, hybrid inheritance, also known as virtual inheritance. Single inheritance. In this type of inheritance, one derived class inherits from only one base class. It is the most simplest form of inheritance. Multiple inheritance. In this type of inheritance, a single derived class may inherit from two or more than two base classes. hierarchical inheritance. In this type of inheritance, multiple derived class inherit from a single base class. Multi-level inheritance. In this type of inheritance, the derived class inherits from a class which in turn inherits from some other class. The superclass for one is subclass for the other. Hybrid virtual inheritance. Hybrid inheritance is combination of hierarchical and multi-level inheritance. Loops and decisions. Loop control statements. A sequence of statement is executed until a specified condition is true. The sequence of statement to be executed is kept inside the curly braces known as loop body. After every execution of loop body, condition is checked, and if it is found to be true, the loop body is executed again. When condition check comes out to be false, the loop body will not be executed. We can see in the figure very clearly. There are three types of loops in object-oriented programming language. Number 1, while loop. Number 2, for loop. Number 3, do while loop. There are two major kinds of programming loops: counting loops, event controlled loops. Counting loop. In a counting loop, the computer knows at the beginning of the loop execution how many times it needs to execute the loop. This kind of loop is defined with the for statement, which executes the loop body for every item in some list. Event controlled loop. In an event controlled loop, the computer stops the loop execution when a condition is no longer true. The while statement is used for this. It executes the loop body while the condition is true. The while statement checks the condition before performing each iteration of the loop. Some languages also have a loop statement which performs the check after each iteration so that the loop is always executed at least once. Counting loops are actually subset of event control loop. The loop is repeated until the required number of iterations is reached. The while statement. The while loop can be addressed as an entry control loop. The while statement is an event controlled loop statement. It is used when you don't know beforehand how many times you will have to execute the body of the loop. The while body keeps repeating as long as the condition is true. We can see in the flowchart very clearly. The loop consists of three important parts. The variable initialization, example int, that is called integer x equal to 0. The condition, example while x less than or equal to 10. The update, variable increment or decrement, x plus plus or x minus minus or x equal to x plus 2. In the variable initialization step, you set up the variable which you are going to use in the condition. In the condition step, you perform a test on the variable to see whether you should terminate the loop or execute the body another time. Then after each successfully completed execution of the loop body, you update your variable. Note that the condition is checked before the loop body is executed for the first time. If the condition is false at the start, the loop body will never be executed at all. Syntax. Now we can see the syntax. The for statement. The for loop is used to execute a set of statements repeatedly until a particular condition is satisfied. It can be called an open-ended loop. Syntax. Now we can see the syntax. Nested for loop. Nested for loop is one for loop inside another for loop. Basic syntax is shown very clearly. Do while loop. In some situations, it is necessary to execute body of the loop before testing the condition. Such situations can be handled with the help of do while loop. Do statement evaluates the body of the loop first and at the end. The condition is checked using while statement. A general format of do while loop is shown very clearly. Jumping out of loop. Sometimes while executing a loop, it becomes necessary to skip a part of the loop or to leave the loop as soon as certain condition becomes true. That is jump out of loop. C language allows jumping from one statement to another within a loop as well as jumping out of the loop. Number 1. Break statement. When break statement is encountered inside a loop, the loop is immediately excited and the program continues with the statement immediately following the loop. Number 2. Continue statement. It causes the control to go directly to the test condition and then continue the loop process. On encountering continue, cursor leave the current cycle of loop and starts with the next cycle. Decision making statements. Decision making is about deciding the order of execution of statements based on certain conditions or repeat a group of statements until certain specified conditions are met. Decision making is handled by supporting the following statements: if statement, switch statement, conditional operator statement, go to statement. Decision making with if statement. The if statement may be implemented in different forms depending on the complexity of conditions to be tested. The different forms are: number 1, simple if statement; number 2, if else statement; number 3, nested if else statement; number 4, else if statement. Simple if statement. The general form of a simple if statement is shown. If the expression is true, then statement inside it will be executed. Otherwise, statement inside is skipped and only statement outside is executed. Example of if using a C++ program is shown. The output is x is greater than y. If else statement. The general form of a simple if else statement is shown. If the expression is true, the statement block 1 is executed, else statement block 1 is skipped and statement block 2 is executed. Example is shown very clearly. The output is y greater than x. Nested if else statement. The general form of a nested if else statement is shown. If expression if false, the statement block 3 will be executed. Otherwise, it continues to perform the test for expression 1. If the expression 1 is true, the statement block 1 is executed. Otherwise, statement block 2 is executed. Example. Now we can see the example. Else if ladder. The general form of else if ladder is shown very clearly. The expression is tested from the top of the ladder downwards. As soon as the true condition is found, the statement associated with it is executed. Example. We can see the example. It will explain very clearly. Relational operators. If statements compare two values in order to make a decision. The relational operators are, we can see the relational operators in table with 3 columns. First column as a heading operator, second column as heading description, third column as example. Objects and classes. The classes are the most important feature of C++ that leads to object-oriented programming. The class is a user-defined data type which holds its own data members and the member functions which can be accessed and used by creating instance of that class. The variables inside class definition are called as data members and the functions are called member functions. For example, in class of animals, all animals have legs and they can move. Here legs are characteristics and moving is a behavior. There are many different animals in this class with different names, but they all possess this behavior and characteristics. Similarly, class is just a blueprint which declares and defines characteristics and behavior, namely data members and member functions respectively, and all objects of this class will share these characteristics and behavior. Classes. Class name must start with an uppercase letter. If class name is made of more than one word, then first letter of each word must be in uppercase. Example, class study tonight, etc. Classes contain data members and member functions and the access of these data. Members and variable depends on the access specifiers discussed in next function. Classes, member functions can be defined inside the class definition or out the class definition. Class in C++ are similar to structures in C. The only difference being class defaults to private access control, whereas structure defaults to public. All the features of OOPS revolve around classes in C++, inheritance, encapsulation, abstraction, etc. Objects of class holds separate copies of data members. We can create as many objects of a class as we need. Classes do possess more characteristics, like we can create abstract classes, immutable classes. Objects. Class is mere a blueprint or a template. No storage is assigned when we define a class. Objects are instances of class which holds the data variables declared in class, and the member functions work on these class objects. Each object has different data variables. Objects are initialized using special class functions called constructors, and whenever the object is out of its scope, another special class member function called destructure is called to release the member reserved by the object. C++ doesn't have automatic garbage collector like in Java. In C++, destructor performs this task. Definition and declaration of a class. A class in C++ combines related data and functions. It makes a data type which is used for creating objects of this type. Classes represent real-world entities that have both data type properties, characteristics, and associated operations behavior. The syntax of a class function is shown below. Here, the keyword class specifies that we are using a new data type and is followed by the class name. The body of the class has two keywords, namely number 1 private, number 2 public. In C++, the keywords private and public are called access specifiers. The data hiding concept in C++ is achieved by using the keyword private. Private data and functions can only be accessed from within the class itself. Public data and functions are accessible outside the class also. Data hiding not mean the security technique used for protecting computer databases. The security measure is used to protect unauthorized users from performing any operation, read, write or modify on the data. The data declared under private section are hidden and safe from accidental manipulation, though the user can use the private data but not by accident. The functions that operate on the data are generally public so that they can be accessed from outside the class, but this is not a rule that we must follow. The class specification can be done in two parts. Class definition, it describes both the data members and member functions. Class method definitions, it describes how certain class member functions are coded. In C++, the member functions can be coded in two ways: inside class definition, outside class definition using scope resolution operator. The code of the function is same in both the cases, but the function header is different. Inside class definition. When a member function is defined inside a class, we do not require to place a membership label along with the function name. We use only small functions inside the class definition, and such functions are known as inline functions. In case of inline function, the compiler inserts the code of the body of the function at the place where it is invoked, called, and in doing so the program execution is faster but memory finality is there. Outside class definition using scope resolution operator. In this case, the function's full name, qualified name, is written as shown. The syntax for a member function definition outside the class definition is shown below. Here the operator known as scope resolution operator helps in defining the member function outside the class. Earlier the scope resolution operation was used in situations where a global variable exists with the same name as a local variable and it identifies the global variable. Declaration of objects. The objects of a class are declared after the class definition. One must remember that a class definition does not define any objects of its type, but it defines the properties of a class. For utilizing the defined class, we need variables of the class type. In C++, the variables of a class are known as objects. These are declared like a simple variable, that is, like fundamental data types. In C++, all the member functions of a class are created and stored when the class is defined, and this memory space can be accessed by all the objects related to that class. Memory space is allocated separately to each object for their data members. Member variables store different values for different objects of a class. We can see in the diagram common for all subjects. Structures and functions. Structures. A structure is like a class except for the default access. Class has default access of private. Structure has default access of public. Structures also allow operator overloading. General format of structure is shown clearly. Structures have two identities: reference to the type, reference to specific object. The public access label can sometimes be ignored since the default state of structure for member functions and fields is public. An object of type myStructureType, case sensitive, declared using is shown below. A structure and a class are practically the same thing. A structure can be used anywhere a class can be, and vice versa. The only technical difference is that class members default to private and structure members default to public. Structures can be made to behave like classes simply by putting in the keyword private at the beginning of the structure. Advantage of structure over class. Older programmer languages like COBOL, Fortran used a similar type called record. This was implemented in C as the structure keyword. Structures are simpler to be managed by the programmer and the compiler. One should use a structure for plain old data, that is called POD, types that have no methods and whose data members are all public. Structure is more efficient in situations that default to public inheritance and where public access is the intended effect. Using a class, you typically have to insert the keyword public in two places. Functions. Functions are the building blocks of C++ programs where all the program activity occurs. Function is a collection of declarations and statements. Need for a function. Monolithic program, a large single list of instructions, becomes difficult to understand. For this reason, functions are used. A function has a clearly defined objective purpose and a clearly defined interface with other functions in the program. Reduction in program size is another reason for using functions. The function's code is stored in only one place in memory, even though it may be executed as many times as a user needs. Function definition and declaration. In C++, a function must be defined prior to its use in the program. The function definition contains the code for the function. The general syntax of a function definition in C++ is shown below. Return type suggests what the function will return. It can be integer, character, some pointer, or even a class object. There can be functions which do not return anything. They are mentioned with void. Function name is the name of the function. Using the function name, it is called. Parameters or variables to hold values of arguments passed while function is called a function may or may not contain parameter list. Function body is the part where the code statements are written, where a and b are sent as arguments and x and y are parameters which will hold values of a and b to perform required operation inside function. Declaration. Function declaration is done to tell the compiler about the existence of the function. Function's return type, its name, and parameter list is mentioned. Function body is written in its definition. Initially, the function sum integer x, integer y is declared without body, then it is called inside main function. The sum integer x, integer y function returns summation of two values. The function is defined where the body of function is mentioned. Arguments to a function. Arguments of a function are the data that the function receives when called invoked from another function. Passing arguments to a function. It is not always necessary for a function to have arguments or parameters. The following example illustrates the concept of passing arguments to function. Some function. It explains the program very clearly. Default arguments. C++ allows a function to assign a parameter the default value in case no argument for that parameter is specified in the function call. For example, we can see the program. It will explain very clearly what is mentioned in the above. constant arguments. A C++ function may have constant arguments. These arguments is or treated as constants. These values cannot be modified by the function. For making the arguments constant to a function, we should use the keyword constant as given below in the function prototype is shown below. Here, the qualifier constant informs the compiler that the arguments having constant should not be modified by the function maximum. These are quite useful when call by reference method is used for passing arguments. Calling a function. Functions are called by the names. If the function is without argument, it can be called directly using its name. But for functions with arguments, we have two ways to call them. Call by value, call by reference. Call by value. In this calling, the technique we pass the values of arguments which are stored or copied into the formal parameters of functions. Hence, the original values are unchanged, only the parameters inside function changes. It is explained in the program very clearly. The value returned by function cal's integer x is 20. Since it is not assigned to the variable x, the value of x remained 10 in the main function. Hence, on printing the value of x, the output is 10. In this slide, we can see the example. The value returned by function cal's integer x is 20 since it is assigned to the variable x. The value of x is updated to 20 in the main function. Hence, on printing the value of x, the output is 20. Call by reference. A reference provides an alias, an alternate name for the variable. That is, the same variable's value can be used by two different names, the original name and the alias name. In call by reference method, a reference to the actual arguments in the calling program is passed, only variables. So, the called function does not create its own copy of original values, but works with the original values with a different name. Any change in the original data in the called function gets reflected back to the calling function. It is useful when you want to change the original variables in the calling function by the called function. We can see the program, then we getting the output as 20. Virtual functions. Virtual function is a function in base class which is overridden in the derived class and which tells the compiler to perform late binding on this function. Virtual keyword is used to make a member function of the base class virtual. Late binding. Late binding function call is resolved at runtime. Hence, now computer determines the type of object at runtime and then binds the function call. Late binding is also called dynamic binding or runtime binding. Problem without virtual keyword is shown below. Output base class. When we use base classes, pointers hold derived classes object. Base class pointer or reference will always call the base version of the function. Using virtual keyword, we can make base classes method virtual by using virtual keyword while declaring them. Virtual keyword will lead to late binding of that method is shown in the program below. Output derived class. On using virtual keyword with the base classes function, late binding takes place and the derived version of a function will be called because base class pointer points to derived class object. Using virtual keyword and accessing private method of derived class, we can call private function of derived class from the base class pointer with the help of virtual keyword. Compiler checks for access specifier only at a compile time. So at runtime, when late binding occurs, it does not check whether we are calling the private function or public function. It is clearly explained in the program, and then the output is derived class. Mechanism of late binding. To accomplish late binding, compiler creates vtables for each class virtual function. The address of virtual functions is inserted into these tables. Whenever an object of such class is created, the compiler secretly inserts a pointer called vPointer pointing to vtable for that object. Hence, when function is called, compiler is able to resolve the call by binding the correct function using the vPointer. Only the base class method's declaration needs the virtual keyword, not the definition. Function is declared as virtual. In the base class, it will be virtual in all its derived classes. The address of the virtual function is placed in the vtable, and the compiler uses vptr vPointer to point to the virtual function. Pure virtual functions. Pure virtual functions are virtual functions with no definition. They start with virtual keyword and ends with equal to 0. Here is a syntax for a pure virtual function. Pure virtual functions can be defined in the abstract class. All the derived class will have this virtual function. The pure virtual function must be defined outside the class definition. If you define it inside the class definition, compiler will give an error. In line, pure virtual definition is illegal. Conclusion. In this chapter, we have covered the following in detail: an overview of C++ programming, Smalltalk, Java, loops and decisions, structures and functions, objects and classes, arrays and pointers, inheritance, virtual functions.